From the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, welcome to NASA's New Horizons Countdown to Pluto. I'm Mike Buckley from APL Communications and Public Affairs, and we're on Pluto's doorstep, getting ready for New Horizons' historic flyby of the Pluto system on July 14th. On July 9th, we're 5 days away, about 3.5 million miles from Pluto. And there's lots going on, so let's start with our operations update. Now, this is a live look inside the New Horizons Mission Operations Center here at the Applied Physics Laboratory. So joining us is New Horizons Project Manager Glenn Fountain from APL. Glenn, thanks for joining us.
Glad to be here.
Let's take a look at the overall operations on New Horizons. The team does a lot to keep New Horizons moving and moving on target. Take us through an operations day. What are those teams doing now?
Okay, but first let's talk about what the spacecraft does, because there is a dance between the spacecraft and what's happening on the ground. So the spacecraft does two major things. One is it points the instruments at Pluto, and then it points the antenna at the Earth so we can communicate, and we can't do both at the same time. So earlier, we actually had taken an image of Pluto. We then turned the antenna to the ground to point toward Earth and transmitted that signal, so we got the image down here early. That image is then processed two different ways. First, the scientists look at it. We all get really excited about that. But also, the navigators use that image to determine where the spacecraft is relative to Pluto. So we can determine if we are on our path to pass by Pluto exactly where we want to pass by it. So after traveling 3 billion miles, we have to hit a box a very certain distance from Pluto, and that box is only 60 miles by 90 miles. So think of a piece of the sky, and after 3 billion miles, you've got to hit that target. We are going right down the center of that. That's what the navigators have done for us. So they're doing that. They analyze that data, and then we get together in the afternoon and determine if we need to make any other adjustments. For instance, we carry on board the spacecraft a knowledge of where Pluto is. So as we go down the timeline, the spacecraft actually knows where to point so that we're taking pictures of Pluto and not of blank space.
Right.
Very important.
Right, an operation with a lot of timing and precision involved.
Very, very precise. So after traveling 9.5 years, we have to know within 100 seconds of when we go by Pluto. So, yeah, it's a little bit of rocket science.
And you see, too, the interaction between those teams. They all have to come together to make sure that all that works.
It is a dance. And the navigators perform their analysis. They communicate with the team itself, and that information goes to the operations team, and they then send up the commands. First they test them, and then they send them to the spacecraft. So, and then we get more data, we go back through that cycle again.
Earlier this week, I think the team was very excited to find out that New Horizons was in encounter mode.
Yes.
So what is encounter mode?
So encounter mode is a special mode that's been set up for the encounter. We've been traveling 9.5 years across the solar system. And if something should go wrong with the spacecraft and it needs help, until this time, it would point back to Earth, set the antenna pointing to the Earth, and basically phone home and say, I don't know quite what to do. I need the ground system people to intervene and take action. Once we're in encounter mode, we do things differently. And the reason for that is, given that it's 9.5 hours round-trip light time, you can't sit there and joystick it. It's got to run automatically. And the data during these 9 days is so invaluable and so important, we're better trusting the spacecraft to bring it back onto the timeline and continue with the operations. So once we get into encounter mode, we do not turn back to the Earth if something should go wrong. It repairs itself through the autonomy system and continues to operating. We think that's the best mode of operating, and it'll be just fine.
That's like full steam ahead.
It's full steam ahead, we're ready to go.
How is the spacecraft? Is everything healthy?
It is perfect. After 9.5 years, we have redundant systems, but everything, both redundant systems working, everything's working perfectly fine.
All right, Glenn, thanks for joining us.
My pleasure.
Now, a challenge of this mission is the distance. Right now, with New Horizons almost 3 billion miles away, it takes 9 hours for operators to have a two-way conversation with the spacecraft. Now, just how far is 3 billion miles? Well, at Daytona International Speedway, where one lap is 2.5 miles, it would take 1,200,000,000 laps to equal 3 billion miles. Now, if you were to drive from New York to Los Angeles, which is 2,448 miles, you would have to make the trip 1,225,490 times. Now, if you were to fly around the equator, which is 24,901 miles, you would have to make the trip 120,477 times to equal 3 billion miles. That's a lot of frequent flyer miles. And because New Horizons was destined to travel so far from Earth and the Sun, it needed a power source designed for deep space. Electrical power for the New Horizons spacecraft and science instruments is provided by a single radioisotope thermoelectric generator, or an RTG, supplied by the Department of Energy. Now, from DOE, to give us an overview is Ryan Bechtel, Power Systems Safety Manager. Ryan, thanks for joining us.
Thanks, Mike.
Let's just start first and say, what is an RTG?
An RTG is a power system which uses the natural decay heat of plutonium dioxide to generate electricity. It does this by using thermocouples, which uses the temperature difference between the very hot plutonium fuel and the cold of space to passively generate electricity.
It's the kind of thing that works in areas where solar power might not be effective or might not be able to reach.
Exactly.
How long have RTGs been in service? How many and how long have they been powering spacecraft?
So RTGs have been used for over 50 years on 27 US missions. The first nuclear-powered mission was the Transit 4A spacecraft, which was a Navy navigation satellite, and it was also an APL mission. That one was launched in June of 1961. Since then, some of the most exciting space missions have used RTGs. They've gone to the moon with the astronauts. On Gale Crater, the Curiosity rover is powered by an RTG. Voyager 1 is currently in interstellar space. And in 2020, the next nuclear-powered mission will be the Mars 2020 rover. RTGs have been used to power missions that have explored Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And next week, we're going to add Pluto to that list.
Let's talk about that too. What does the RTG on New Horizons do for the spacecraft? How does it help it work, and how much power does it give it?
So the RTG on New Horizons is the lifeline for the spacecraft. It provides enough heat to keep all of the instruments warm in the very coldness of space. It also produces all the power. This is for everything for the computer, communications, and all the science instruments. And during the Pluto encounter next week, it'll produce about 202 watts of electricity. Now, 202 watts isn't a lot of power. It's just enough power to produce for about 2 incandescent light bulbs or a video game console. But it's more than enough to supply everything for the New Horizons spacecraft.
I mean, and that's through Pluto too. How long would the New Horizons spacecraft last with its power source?
We fully expect the RTG to continue producing enough power for the spacecraft and for its instruments through the early 2030s. That's certainly more than enough time to power the encounter next week, to send all that information back and potentially explore another Kuiper Belt object.
So much more ahead.
Absolutely.
All right. Well, Ryan, thanks for joining us.
Thank you for having me.
Now, the sun might not be strong enough to power the New Horizons spacecraft, but it is brighter at Pluto than you might expect. Now, people from around the world are learning this by checking Pluto Time, the NASA website where you can find the moment during dawn and dusk each day where the illumination on Earth matches that of noon on Pluto. For a science update, we welcome Fran Bagenal, a New Horizons co-investigator from the University of Colorado at Boulder. Fran, thanks for joining us.
It's a pleasure.
Now, with Pluto Time, it's designed to give an idea of how bright it is at Pluto. But I'm also curious, too, if I was standing on Pluto, what would I see?
Well, the most exciting thing would be the big moon, Sharon. Okay, so if you think of our moon, you look up, full moon, it's about the size of a little finger like that. If we were on Pluto, looked up at Charon, we would see a moon that's 3 fat fingers across up in the sky. So big, but more, it stays there if you're on one side. Now, if you're on the other side, you'd never see it. Never, ever, ever would you see Charon in the sky. You'd see the other moons go by. But because they're in that synchronous orbit, you'd see it one side and not the other.
You're already having an idea that it's a fascinating place to begin with. And now, as New Horizons gets closer, we're getting better and better looks at Pluto. In fact, even to the point where some of the features we're seeing, we can give them nicknames. So what are we seeing in some of the latest pictures that have come down?
Well, you know, they're a little less fuzzy. We're beginning to see features, dark regions, light regions. We're beginning to see sort of shapes a little bit. In fact, they're calling this thing, big black thing, the whale. A little round thing, looks a bit like a donut. And, you know, they're still fuzzy. We can't really say what the geology is, but we're getting there. We're getting close.
I mean, they're interesting enough, and so the pictures are captivating us, you know, to see this too. But New Horizons is more than the pictures.
Absolutely.
Now you lead the mission's particles and plasma team. So in particular, what are you looking for at Pluto?
Well, the most interesting thing to me is the fact that we've got all these ices on the surface, and the ices evaporate, they move out to make an atmosphere. So it has an atmosphere of nitrogen, much like the atmosphere here in this room, but that makes an escaping atmosphere because the gravity is a little weaker, and it moves out and escapes and out into space. It makes a big region that is actually comparable in size to that of the Earth, this escaping atmosphere region. And the particles move away, and what happens then is, as these particles move away, is the material from the sun comes in and interacts with that atmosphere. So from the sun, we have protons and electrons that come along, stream away, and ram into this whole region. And that material is ionized, the material from Pluto. And when it becomes ionized, it gets picked up by the solar wind and carried away. So there's this big interaction region. We don't really know the size, but we're going to fly right through it. And the particles and the plasma instruments, the SWAP and Pepsi, will measure those particles as we go through.
Now, there's a lot of things that will help the team complete the picture of the Pluto system. And there's the geology, the geophysics, where we see a lot of the pictures. And you mentioned what's going on with particles and plasma. There are other elements of this too, to study the atmosphere, to look at the composition of bodies on the surface. It seems like they'll have to come together to get that complete picture of what's happening at Pluto.
So we have a really exciting situation with Pluto because we have an atmosphere, we have a surface, we have this ice that's evaporating, we have the interaction with the solar wind and so on. But what's really kind of interesting is that they all come together. If you think about it, right now the atmosphere is escaping, but when Pluto is much, much further away from the sun, what happens is it freezes down and the solar wind hits the surface and interacts with those ices. It radiates those ices. And so the methane and the nitrogen and so on, the chemical reactions occur that make that browny, gunky, oily, hydrocarbon organic material, the brown gunk, we like to call it, on the surface, and makes it that reddish, brownish, darkish color.
I mean, so I say everything, there's like surprises now, even starting as we're getting this closer. Yeah. You were on the Voyager team when it flew past Neptune in 1989 to give us our first look at a new planet until now. And so I'm wondering, are you starting to feel the same working on New Horizons as you did then?
Well, after Triton, we were all like, well, no, is there life after Triton? What do we do? Where do we go? But of course, now we know there's Pluto, and indeed, it's the same sort of thing. We're beginning to feel, oh, we're going to get there, we're going to get there. It's going to be really cool. It's just really exciting.
The excitement, I know, getting there days in and seeing what's coming up every day, too.
Each day's different.
Thanks, Fran. Join the conversation via Twitter, Facebook, and other social media platforms talking about the July 14th flyby. Send questions at #PlutoFlyby. Mission information, along with new images, are available online at www.nasa.gov/New Horizons. So that's the latest from NASA's New Horizons mission on Pluto's doorstep. We are 5 days away, less than a Pluto day away from the flyby. 3.5 million miles to go, the countdown to Pluto continues. I'm Mike Buckley, and for the New Horizons team, thanks for watching.